This is recording for Edexcel Further Pure 1, Further Vector Geometry, Section 2.2, Direction Cosines of a Line. This diagram shows a line in three-dimensional space and a vector A which is parallel to the direction vector of the line, which is passing through the origin here. The angle that that vector A makes with the x-axis is marked in as alpha. And of course we can see that this point here must have the same x-coordinate as the point at the end of the line there. So therefore we can say that this length here is mod x, or just x, and the length of the line is mod A. And therefore the cosine of alpha is equal to x over mod A. So we can say that cos alpha is equal to x over the length of A, mod A. And this is what we call one of the direction cosines of the line. That one is referred to as being L. So the line, the angle that the line makes to the x-axis, L, has cosine alpha equal to x over A. And we can do a similar thing for the angles to the y and z axis respectively. So here we have the three direction cosines, L cos alpha equal to x over A, M cos beta, which is y over mod A, and N, which is cos gamma, is z over mod A. We've seen the idea now of the direction cosines L, M and N. What I want to do is to look at what happens if we take L squared plus M squared plus N squared. Now obviously all we need to do is to square each of these, so we get x squared over mod A squared plus y squared over mod A squared plus z squared over mod A squared. But x squared plus y squared plus z squared is just equal to mod A squared. So this is equal to mod A squared divided by mod A squared, and that's equal to 1. So what we've shown there is that if we have the direction cosines L, M and N, they are such that L squared plus M squared plus N squared must always be equal to 1. Another fact that is true is that the ratio of the direction ratios x to y to z must be the same as L to M to N. And we can see that simply by dividing through on the left hand side by mod A in each case. And of course then this gives us the definitions of L, M and N. So x to y to z must be equal to L to M to N. So before you go on, just pause and make sure you understand everything which is on this slide. Now I want to use these ideas to look at an example that might be asked in an A-level question. So here we have a line which has been given to us as r minus a cross b is equal to 0. So this is in the form r minus a cross b is equal to 0 vector. We're asked to find L, M and N, the direction cosines of the line, and hence its Cartesian equation in the form x minus a over L, etc. So as I said, this equation is in the form r minus a cross b is equal to 0 vector. And it's this vector here that we're interested in, because that's the one that, if we have it going through the origin here, allows us to work out the direction cosines. So the direction that we need goes through 2, 4, -1, and so the direction cosines will be found by taking those values divided by the length of this vector. So we want to work out, in this case, mod of the vector b here. So mod b will be the square root of 2 squared plus 4 squared plus -1 squared, and that's equal to the square root of 21. And therefore the direction cosines are given by L is equal to 2 over root 21, M is equal to 4 over the square root of 21, and N is equal to -1 over root 21. Now once we've got those, we can then work out the Cartesian equation. So we want it in the form x minus a over L equals y minus b over m equals z minus c over n, where L, m and n are the direction cosines that we've just found. Well, from our equation that's given, we know that this is vector A and this is our direction vector B, and so we can write its standard Cartesian form as being x minus 1 over 2 is equal to y plus 1 divided by 4 is equal to z minus 2 divided by -1. So remember that we are taking these values on the top line, subtracting those from x, y and z respectively, and then we have on the denominator the values from the direction vector, so 2, 4 and -1. Now what we need to do now is divide the denominator throughout by the length of b, which we found as being root 21. So this gives us x minus 1 over 2 divided by root 21 is equal to y plus 1 divided by 4 over root 21 is equal to z minus 2 divided by -1 over root 21. So that's in the form x minus 1 over L is equal to y plus 1 over m is equal to z minus 2 over n, where L, m and n are the direction cosines. There we are, written out. So just again pause the video and make sure that you understand everything on that slide. So now this is going to be a general result that we can simply go from our standard equation in the form given there to the form with L, m and n as the denominators rather than b1, b2 and b3. Well, that's the end of this video, and in the next one we'll be looking at using the cross product to give us the equation of a plane.